back. This is Terrence Mullins, and in this lecture we're going to be talking about ocean circulations. Now I know what you might be thinking when you hear I'm mentioning ocean circulations. Terrence, this isn't an oceanography class. If I wanted oceanography, I would have taken oceanography. Well, the ocean and the atmosphere actually are greatly related to one another. And in fact, I tell a lot of my colleagues and a lot of my friends that if I wasn't a meteorologist, I'd be an oceanographer. And the reason why is because the ocean has major implications on the atmosphere. So yes, we still need to talk about this. But one little interesting piece I'm going to put at the end of this lecture is I'm going to talk about why the California drought happened and how the ocean may have played a role in it. Now let me stress, may have played a role in it. All right, so let's jump in. So first let's talk about ocean currents. Now, ocean currents are like giant rivers of moving ocean water. The ocean does not stay stagnant in one place like a lot of us might think. Rather, the ocean actually travels in these large circulations on the ocean. Now there are three types of currents that I want you to know about, and I'll explain each one of these in the next few slides. The first type is called equatorial. These are currents that travel along the equator, and they're blown by the trade winds. The trade winds push this water from the east to the west. The next type of current, and this is the one, these next two might throw you off a little bit. The next kind of current is what's called a western boundary current. Now, when I use the word western boundary, I'm talking the western boundary of the ocean. I'm talking about the western boundary of the ocean. Here's what I mean. We're here in California. We're West Coast, right? And I'm sure that you've heard that before, West Coast for life, or West Coast versus East Coast battle, and so on. We're on the West Coast, but that's from a continental perspective. We are on the western end of North America. However, if you were to look at the Pacific Ocean as a whole, Hawaii's somewhere in the middle. We're actually on the eastern end of it. On the other hand, East Asia, China, Japan, Vietnam, Indonesia, Australia, they are all on the western end of the Pacific Ocean. So with that said, when I say western boundary current, I'm talking about the western boundary of the ocean. Western boundary currents are warm ocean currents, and they occupy the western end of an ocean basin. Along these currents, warm water is carried from the equator up towards the poles. On the other hand, on the other side of the ocean, the eastern boundary, cold water is carried from the poles down to the equator. This is what we experience here in California. In California, cold water is transferred from the Gulf of Alaska down the California coastline. Now we'll talk about how this influences weather in a couple of moments. But here's how these look. Here are the western boundary currents, and again, they occupy the western end of ocean basins, and they start near the equator and they move up towards the poles. So they're very warm currents. Good examples of this are the Kuroshio Current, the Gulf Stream, the East Australian Current, the same one mentioned in Finding Nemo, EAC, dude, and so on. Then there are the Eastern Boundary Currents. Most famous one is the California Current. This is what keeps our waters nice and cold. Then there's the Canary Current in the Eastern Atlantic, and the West Australian Current in the Eastern Indian Ocean. And then finally, the Equatorial Currents. These equatorial currents move water from east to west, and it blows along the trade winds. Now, there is a countercurrent that's also present near the equator, but we're not going to talk about that. We're just going to stick to western, eastern, and equatorial. Now, what drives these ocean currents? Well, believe it or not, it all has to do with wind. And actually, it all has to do with those subtropical highs that we talked about in the last lecture. In the last lecture, I mentioned that at 30 degrees north and south, we have high pressures. Well, we know that winds rotate clockwise around a high pressure in the northern hemisphere, counterclockwise around a high pressure in the southern hemisphere. Well, these ocean currents rotate in the exact same direction. So it's really these high pressures that drive these ocean currents. Now, with that said, I mentioned this a little bit in the last class, but just so that you can write it down and have it memorized, if that's how you do it. Memorization's not the best thing to do. But between the equator and 30, winds blow from east to west. Those are called the trade winds. Between 30 and 60, the westerlies blow from west to east. And between 60 and the poles, the easterlies blow from east to west again. All right? And this is all caused by that three-celled model of circulation that I talked about in the last class. So if you need to go back and review that, I strongly recommend you do it. Now, how do these ocean currents actually influence climate? Well, they influence climate because they carry water with them. And that water greatly influences local temperatures. For example, a few lectures ago, or a few modules ago, I mentioned the comparison between Arica and Rio de Janeiro. Arica was located in Peru on the west coast of South America in the eastern Pacific and was subject to a cold current. And Rio de Janeiro was, on the other hand, on the east coast in the western end of the Atlantic basin, subject to a warm current. And you actually notice everything else about the two is pretty much the same. Same latitude, same elevation, same proximity to the ocean. But because of the difference in ocean current, Arica was on average 10 degrees colder year-round than Rio de Janeiro. Tying that all together, warm ocean currents create warm, wet weather. Cold ocean currents create cool, dry weather. If you're doing this week's module activity, nice little hint here, this plays a huge role in it. If you're next to a warm ocean current, even if you are in a relatively dry latitude, that warm ocean current might actually help overcome that. For example, the eastern end of the United States, even the areas near 30 degrees north, are actually very wet because they're next to the Gulf of Mexico. On the other hand, the Atacama Desert in South America is right next to a cold current, and it's a lot drier there.